What is up, guys? Welcome to another episode of Math Made Easy. This is Kirk Smith, and today we will be talking about parabolas. Now, this will probably end up, definitely will be at least 2 parts, maybe 3, maybe even 4, depending on how much parabolas you guys want. So, here we are. Y equals x squared. So, that's the parabola equation, right? You might think, okay, what is it really different from the equations we looked at a couple of days ago? It's this little mini 2 up here, guys. This is a second degree equation, meaning the degree of an equation, or a polynomial, is the highest exponent it has. So this has an x squared in it, so it would be of degree 2. Second degree equations are called quadratic equations, and what they graph as are called parabolas. Now this parabola would look something like this. Oops, sorry, this is a very not looking like y equals x squared. Actually, you know what we'll do? Go over here. So this y equals x squared parabola is this basic parabola. It will come down and touch the axis right here. So you can see if you zoom in, it looks like a flat line. If you zoom out far enough, it looks like a vertical line. Parabolas are not linear. Previously we've talked about linear equations on this channel, right? Equations like y equals x, first degree equations, and those are lines, right? And they, no matter how far you zoom out or in, they will always be lines. So what does this represent? The y is what the x is squared, right? So when the x is 2, the y is 4. 2 squared is 4. When the x is very small, 0.05, the y is 0.0025, which is that squared. And these get infinitesimally small. And this is technically not 0 here. It's just kind of rounding it to 0, but that's because that's what Desmos does. But like, if we had it here, we would be at 10 to the minus 14th. 2 times 10 to the minus 14th small. But that's still above 0, and when you get close enough, it gets so unimaginably small, and then you hit 0, 0, because 0 squared is 0, right? So you can see it kind of makes a kind of a upward kind of smiley face. So let's look at a parabola of a little bit more significance. Well, I mean, that's not of more significance necessarily, but that I can demonstrate a little bit more with. So you can see this parabola, y equals x squared minus 1, it has 2 zeros, minus 1 and 1, which makes sense, right? Because 1 squared is 1, and 1 minus 1 is 0. It also has a vertex, which, you know, of course, it's a curve. It's not like a point vertex, but we still call it a vertex at minus 1. So you can see it's kind of curving around, kind of a point right around there, and this has this vertex at minus 1. So if we were going to analyze this parabola, we would say the zeros are at 0, comma, 1, comma 0, and -1, comma 0, and we would say the vertex is at 0, comma -1. So that would be kind of the important points to say of this parabola. What if we were to have a much more complicated parabola? Like x squared plus, I don't know, let's go with plus 5x. What is it doing? Wait. What is this thing doing? Okay, so guys, I got it back working. I'm sorry about that. I don't know what it was really doing there. So this is the equation x squared plus 5x plus 4. So let's do some analysis on this parabola. One of the vertexes is at -4, comma 0. One is at -1, comma 0. One is at -2.5, comma -2.25. And then the y-intercept is at 0, comma 4. So that's another parabola that we could analyze a little bit. What's the point of all this? How are we going to be solving parabolas, right? So in fact, this whole thing is just it's something like this, except it's x plus 1 times x plus 4. But here I have a different equation, x plus 1 times x plus 3 equals 0. And we will multiply these two together to get a parabola equation. So if we multiply, we use a multiplication method called FOIL. So first terms multiplied together, x and x squared plus 1 times x, this x, for that was actually inner, and then outer plus minus 3x, so first, outer, inner, last. Actually, sorry guys. And then minus 3 times minus 1. No, minus 3, oh my god, I cannot talk today. Minus 3 times 1 is minus 3. So this is our equation for this. We would simplify it by combining these like terms. Any term with the same degree, so these are both x to the first terms. This is x to the second, this is x to the 0. So that would just make this into x squared minus 2x and then minus 3. So that's going to be our equation for this. Now let's go back to this and pay attention to these numbers. Wait, oh. Minus 3. Did I write plus 3? No, I wrote minus 3. So here's our function. Now I told you to pay attention to these numbers, this 1 and this 3, right? First x-intercept is at minus 1 comma 0. Second x-intercept is at 3 comma 0. So, but you might be confused because this is negative 3 and this is positive 1. But think, if I plug in 3 for x here, then 3 minus 3 is going to be 0, and anything multiplied by 0, so no matter what this is, as long as it's multiplied by 0, it's going to come out as 0. Same thing here, minus 1 plus 1 is 0. So that's kind of, our first kind of realization of graphing. Now I'm going to do one more quick problem with you guys. What do we think if we have an equation like this and we're told to find the zeros? So we know it's going to be, this is a trinomial, 3 terms of different degree, and we know we're going to, because this is an x squared, it's only 1x squared, so we'll put an x here and an x here. So now we list the factors of 8, so 1 and 8 multiply to 8, and then 2 and 4 also multiply to give 8. And we'll try both of those. So if 1 and 8 were the correct ones, we would have x plus 1 times x plus 8, so we would have 1x here. We would have 8x here. Those would combine to give a 9x, and we have a 6x. Let's try the next ones, 2 and 4. We have x plus 2 here, and then x plus 4. 4 times x is going to be 4x, and then 2 times x is going to be 2x, and then added together, those are going to make 6x. So we know that these are the correct ones. It doesn't matter which order you put these in. Remember, 9 times 6 is the same as 6 times 9. It's just like that. So, and this, in fact, gives us the same equation if you multiply it out. Isn't that brilliant? So now, given this, what do you think the zeros of this are going to be? If you guessed minus 2 and minus 4, that's going to be correct. And let's just check real quick. It was this one. Oh, it was plus. Sorry, guys. 6x plus 8 minus 4 minus 2. There you go, guys. So I hope that we've learned how to find zeros of parabolas today. Next video I will be talking about, maybe not the next one, but the next one I do on parabolas I will be talking about how these all kind of come, how, we find the vertex here. But anyways, guys, thank you for watching. This is Math Made Easy. Have a great day.